AI learns from data through repeated mistakes and constant self-correction cycles. At first, AI knows absolutely nothing about the task it must solve. It begins its learning journey using large amounts of raw data. This data can include images, text, numbers, or even audio signals. Each piece of data acts like an example for the AI system. The AI tries to understand patterns hidden inside these examples, but initially its predictions are mostly random and inaccurate. This is completely normal in the early stage of learning. The AI does not understand data like humans do. Instead, it performs mathematical calculations on the input data. These calculations help it make an initial guess or prediction. For example, it may guess whether an image contains a cat, or it may predict whether an email is spam or not. These early guesses are often incorrect and unreliable, but every wrong guess becomes a learning opportunity for improvement. After making a prediction, AI compares it with the correct answer. This correct answer is already provided in training data. The difference between prediction and truth is called an error. This error tells the AI how wrong its guess was. A larger error means a bigger mistake in prediction. A smaller error means the AI is close to correct. The AI then uses this error as feedback for learning. This feedback is the most important part of the learning process. Without feedback, the AI cannot improve its performance. It simply keeps repeating the same mistakes again and again. That is why labeled data is extremely important in training. Labeled data means inputs with correct answers already attached. This helps AI understand what the correct output should be. The system learns by constantly comparing guess and truth. This cycle is repeated thousands or even millions of times. During this process, AI adjusts its internal settings. These settings are called weights and biases. Weights decide how important each input feature is. Bias helps adjust the final output decision. Together, they control how the AI makes predictions. When AI makes a mistake, it slightly changes these values. This adjustment helps reduce errors in future predictions. The goal is to minimize mistakes as much as possible. This process is known as optimization. Optimization slowly improves the AI's accuracy over time. Think of it like tuning a musical instrument. Each adjustment brings the sound closer to perfect harmony. Similarly, AI adjusts itself to make better predictions. At first, changes are large and frequent. Later, adjustments become smaller and more precise. This shows that the AI is learning effectively. The system is not memorizing answers directly. Instead, it is learning patterns from the data. These patterns help it generalize to new situations. Generalization is the real goal of machine learning. Without generalization, AI would only memorize training data. That would make it useless in real-world scenarios. True learning means performing well on unseen data. This is what makes AI powerful and practical. The entire process depends on continuous feedback loops. Guessing, checking, and adjusting happen repeatedly. Over time, errors become smaller and smaller. The AI slowly becomes more accurate and reliable, but this improvement only happens through enough data. More data usually leads to better learning results. Less data can make learning weak or unstable. That is why data quality is extremely important. Now we move deeper into how AI improves itself internally. This involves something called weight optimization in detail, and that is where the real intelligence begins to emerge. AI becomes smarter by constantly adjusting internal mathematical values during training. These internal values are called weights and biases in the model. They control how the AI processes input data. At the beginning, these values are set randomly. That is why early predictions are usually very inaccurate. The AI then starts comparing predictions with correct answers. This comparison produces an error value every single time. The system uses this error to understand how wrong it is. Then it begins adjusting its internal parameters step by step. This adjustment process is called learning from feedback. Each small change helps reduce future errors gradually. The goal is to reach the lowest possible error level. This process is repeated many times across the dataset. Millions of examples may be used in training. Each example helps refine the model's behavior. To make learning efficient, AI uses special algorithms. These algorithms guide how adjustments should be made. One important method is called gradient descent. It helps AI find the best direction to reduce error. Think of it like walking downhill to reach the lowest point. The lowest point represents the smallest possible error. Each step improves the model slightly. Small improvements add up over time. Eventually, the AI becomes highly accurate. This process is automatic and requires no human intervention. However, humans design the learning rules and structure. That is why machine learning is still human-guided intelligence. The AI only follows mathematical instructions. It does not understand meaning or context like humans. It only optimizes numbers to reduce mistakes. Another important concept is the learning rate. Learning rate controls how big each adjustment is. If it is too high, learning becomes unstable. If it is too low, learning becomes very slow. Finding the right balance is very important. Good training requires carefully tuned settings. These settings are called hyperparameters. They are chosen by humans before training begins. AI does not decide them on its own. This shows human involvement in the learning process. During training, AI repeatedly passes through the data. Each full pass is called an epoch. One epoch means seeing all training examples once. Many epochs are needed for good learning results. With each epoch, accuracy improves gradually. Error decreases step by step over time. Eventually, the model stabilizes at high performance. At this stage, learning slows down significantly. The model is now considered trained and ready, but it still needs testing on new data. Testing ensures the AI is not just memorizing data. It checks whether the model can generalize well. If performance drops, it may be overfitting. Overfitting means memorizing instead of learning patterns. This is a common problem in machine learning. To fix it, techniques like regularization are used. These techniques improve general learning ability. Proper testing ensures real-world reliability. Only then can the model be safely used. After testing, it enters real-world deployment. Now it can make predictions on new inputs. This is where AI becomes practically useful. The learning process continues even after deployment sometimes. Some systems keep improving with new data. Next, we will explore real-world examples of this learning. The way AI learns becomes clear when we see real-world examples everywhere. One of the simplest examples is email spam detection systems. AI is trained using thousands of emails marked as spam or not spam. It studies patterns like words, links, and message structure. Over time, it learns what spam emails usually look like. Then it can predict new emails with high accuracy. Another example is recommendation systems on streaming platforms. AI learns from what you watch, like, or skip. It finds patterns in your behavior and preferences. Then it suggests movies or videos you may enjoy. This learning happens continuously in the background. Social media feeds also use the same learning process. AI decides which posts appear first on your screen. It predicts what content will keep you engaged longer. This is all based on data patterns, not human thinking. In healthcare, AI learns from medical images and records. It is trained on thousands of X-rays and MRI scans. It learns patterns linked to diseases or abnormalities. Then it helps doctors detect illnesses faster. This improves diagnosis accuracy and saves lives. Another example is voice recognition in smartphones. AI learns from millions of voice samples. It studies tone, accent, and speech patterns carefully. This helps it understand spoken commands correctly. Virtual assistants use this learning to respond to users. Even small errors improve the system over time. Navigation apps also rely heavily on AI learning. They study traffic patterns and road conditions. Then they predict the fastest route for users. This makes travel more efficient and time-saving. In banking, AI learns to detect fraud patterns. It studies normal transaction behavior of users. Then it identifies unusual or suspicious activity. This helps prevent financial losses in real time. Stock market prediction systems also use AI learning. They analyze historical price data and trends. Then they try to predict future market movements. Though not always perfect, they improve decision-making. In agriculture, AI learns from crop and soil data. It helps farmers improve yield and reduce waste. Even gaming uses AI learning techniques. Game AI learns strategies by playing millions of matches. It improves its performance through repeated experience. Some AI systems have defeated human champions. This shows how powerful data-driven learning can be. Online shopping platforms also use AI learning heavily. They analyze your browsing and purchase history. Then they recommend products you are likely to buy. This increases sales and improves user experience. Every recommendation is based on learned patterns. AI learning is not limited to one industry. It is used in almost every digital system today. From security cameras to search engines, it is everywhere. These systems continuously learn from new data. This makes them smarter over time automatically, but they still do not truly understand meaning. They only recognize statistical relationships in data. That is why human supervision is still important. Data quality also affects how well they learn. Better data leads to better predictions and results. Poor data can create wrong or biased outcomes. That is a major challenge in real-world AI systems. Understanding these examples makes learning process clearer. Now we move toward final insights and limitations, and how AI learning will evolve in the future. AI is becoming smarter every year, but it still has important limitations. AI depends heavily on the quality of its training data. Poor data can create inaccurate or unreliable predictions. This is why clean and trusted information is very important. AI also cannot truly think like humans today. It recognizes patterns instead of understanding real meaning deeply. Human intelligence still remains far more flexible and emotional. AI systems only follow learned mathematical relationships from data. They do not have consciousness or personal awareness. This makes AI powerful, but still limited in many ways. Another major challenge is bias in training data. If data contains unfair patterns, AI may repeat them. Developers must carefully test systems for fairness and safety. Responsible AI development is becoming more important worldwide. Companies are now focusing more on ethical AI practices. AI systems also require massive computing power for training. Advanced models need expensive hardware and large energy resources. This can make development difficult for smaller organizations. Researchers are working on making AI more efficient. Future systems may require less power and data. Despite challenges, AI continues improving at an incredible speed. New learning methods are making systems more accurate daily. AI is becoming better at recognizing images and language. It is also improving in prediction and automation tasks. Many industries are already transforming because of these advancements. Healthcare is using AI for faster medical analysis. Education platforms are personalizing learning experiences using AI. Businesses are improving customer support through smart assistants. Transportation systems are becoming safer with intelligent automation. These applications are only the beginning of AI's growth. Future AI systems may learn more like humans. They could adapt faster to completely new situations. AI may eventually require fewer examples for learning. This would make systems more flexible and efficient. Researchers are also improving transparency in AI decisions. Transparency helps humans understand why AI makes certain predictions. This builds trust between people and intelligent systems. Trust will become essential as AI becomes more common. Human supervision will still remain extremely important. AI should assist humans instead of replacing them completely. The future of AI depends on responsible human choices. Ethical development must grow alongside technological advancement. Safety, privacy, and fairness should always remain priorities. Governments and companies must work together carefully. This ensures AI benefits society in positive ways. AI learning is one of humanity's greatest technological achievements. It allows machines to improve through experience and feedback. But machines still rely on human-designed systems and data. Humans remain responsible for how AI is used globally. That responsibility will shape the future of technology itself. AI is not magic, even if it sometimes feels magical. It is the result of data, algorithms, and continuous training. Understanding this process helps reduce fear and confusion. It also helps people use AI more effectively. Knowledge is the key to responsible technological progress. AI will continue changing industries and daily life rapidly. New breakthroughs will appear faster in coming years. Some changes will make life easier and more productive. Others will create important ethical and social questions. Humanity must prepare carefully for both opportunities and challenges. The relationship between humans and AI is still evolving. Collaboration between both will become more important over time. AI can enhance human abilities when used responsibly, and the future of AI learning has only just begun. The next generation of intelligent systems may change the world forever.